Here in this video, we're going to look at a topic we've talked about before, and I know it's been a while, so I want to look at maybe one more example here, dealing with the natural log though. We want to find the equation of the tangent line at the point 0, 4. So we've been looking at finding the derivative, but we really haven't looked at finding that equation of the tangent line at the point because we know the derivative gives us the slope at any point on the curve. But I want to take a time to go through at least one example here of finding the equation for our tangent line. So if we're trying to find the equation of the tangent line at the point 0, 4, the graph of this equation is roughly going to look something like this here. The 4 minus x squared minus ln of 1/2 x plus 1, you're going to get a graph that looks similar to this, kind of a curve of this nature. And what we're trying to find is, we want to know what is the equation of the, let me draw this a little bit better, it has a little bit more of a curve this way. But we want to find the equation of the tangent line at the point 0, 4, and here's our point 0, 4. And if we think of the tangent line, it looks like it's going to run somewhere right through here that's tangent to that point. And we're trying to find what's the equation of this line at the point 0, 4. So we know that we have the point, and if we want to find the equation of a line, we must also find the slope. Well, that means we can calculate the derivative. So if we find the derivative, f prime of x, the derivative here of 4 would certainly just be 0. And minus x squared, that becomes a negative 2x. Minus, and now we take the derivative here of 1/2 x plus 1, that's our u, because remember, natural log, we're looking for du over u. So we would have 1/2 is the derivative all over the u, which is 1/2 x plus 1. And then we can simplify from here. We have negative 2x minus, and if I want to rewrite this a little bit better, this is 1/2 multiplied by all this. If you can see it better this way, I'm going to take the 1/2 here and bring it out front. So it's 1/2 multiplied by 1 over 1/2 x plus 1. Okay, I think this way, I think visually you can see this a little bit better. And what's going to happen is if we take and think of multiplying here, we can think of distributing the 1 up here to the 1. So 1 times 1 is 1. But then we're going to take the 2 and distribute that to the bottom. So we're going to get 2 times 1/2 and then 2 times 1. So therefore, we have 1 over, well, 2 times 1/2 is just going to cancel the 2's, and you're left with 1x. And 2 times 1, we'd be left with plus 2. So there's the derivative. And we don't really need to simplify this any further because remember, we want to find the derivative at the point, at our point up here, 0, 4. So I'm going to evaluate the derivative at our point 0, 4. So that means the x value, what is the derivative when x is 0? Well, if we plug 0 in for x, this is going to go to 0 minus x is 0, so that would just be 1/2. So therefore, it looks like we're going to end up with a slope of 1/2. Okay, so keep in mind here, this is going to be our slope at the point 0, 4. So if we have our point, which is the 0, 4, and if we want to find the equation, well, if we have the slope and a point, then we know that we have y equals mx plus b. We could use this case, the slope-intercept form, because this is our y-intercept at 0, 4. So we could think of this as simply y equals negative 1/2 x plus 4, and that's going to be the equation of our tangent line above. Now, if we didn't have the y-intercept here, you could certainly plug in your x and y and then plug in the slope, and we could solve for b in order to find this. Or some of you may be familiar with using point slope. We certainly could have used y minus y1 equals m times x minus x1. We could also use that to find the equation where x1 and y1 would be our point, the 0, 4, and then m would be the slope. So just wanted to reinforce and keep in mind that when we find the derivative, we're really finding a formula that's going to give us the slope at any point on the graph. Or instead of the slope, we can think of that as the rate of change. You know, what is the change here at this graph? At this point 0, 4, the change we found to be negative 1/2, which means as our y is going down, our x is going 2 to the right. So as our y decreases 1, our x is increasing 2. So keep in mind that this is one of the applications as far as what we can do with finding the derivative of a function.